Okay, so we're classifying triangles, and this is where if I just read a question, so question 3, classify each of these triangles according to their side lengths, scalene, isosceles or equilateral. If I don't know what those things mean, I'm not going to be able to do the questions. So it's really important that you make sure you're having a good look at your key ideas, and you even are flicking back to it in your book. Obviously, it's impossible to remember these things off by heart straight away. You're just going to have to continue to practice them. But here, if I flick back to my key ideas, I can see that a scalene has 3 different sides and 3 different angles. An isosceles has 2 equal sides and 2 equal angles. And an equilateral triangle, everything's equal, the sides and the angles. So let's have a look at these ones. 3A, that's obviously an equilateral. I'm just going to write an E. For B, we have 2 sides the same and 2 angles the same, so that's going to be an isosceles. And for C, they're all different, so that's a scalene triangle. Okay. For question 4, it says classify each of these triangles according to their angles. So an acute, a right, or an obtuse. So once again, if we're having a look at that, an acute, a right, or an obtuse. So here in our key ideas, we have an explanation of what all those sort of things are. So an acute angled triangle has all acute angles. Right angle has 1 right angle in it, and an obtuse has 1 obtuse angle in it. Okay, so let's have a look here. For 4A, obviously it's going to, for 4A it's obviously going to be a right angle triangle. So right angled. And for B, we've got an obtuse angle in there, which is more than 90 degrees. So it's going to be an obtuse. And for C, it's going to be an acute angled triangle. Okay? For 7, what is the smallest number of identical equilateral triangles needed to form these shapes? Alright, what's the smallest number of identical equilateral triangles needed to form each of these shapes? So a diamond. So a diamond looks like this. Alright, and if I had 2 equilateral triangles on either side, that would give me a diamond. So for 7A, we only need 2. For B, it asks us an equilateral triangle made up of many other equilateral triangles. So if I have an equilateral triangle, and I have 1 equilateral triangle on the bottom, another one here, another one here, like that, and then I'll need a couple. Oh, actually I don't need 3 on the bottom, 2's enough, and then I put 1 on top like this. I get myself an equilateral triangle. So that's 1, 2, 3, 4. 4 triangles will give that to me. So if I have 2 on the bottom, 1 to fill in the hole here, and 1 that goes on top, that will give me an equilateral triangle. So 4 of them. Okay, once again, in this topic, keep referring back to your key ideas if you don't understand a certain topic.